Today we're talking about solving quadratics. A quadratic equation always has an exponent of 2 every time. And the standard form for a quadratic equation is y equals ax squared plus bx plus c. The U-shaped graph to the left here, this is called a parabola. And the highest point or the lowest point on the graph, that's going to be what we call the vertex. It's this point right here where the parabola changes direction. That's known as the vertex. The points where the graph crosses the x-axis are called the zeros. And so really when we say solve a quadratic equation, usually what we're referring to is finding the zeros. The points where the graph crosses are also called the solutions to the quadratic equation. And a quadratic equation can have 0 solutions, it can have no solutions. It could have 1 or it could have 2, it just depends. So when we say we're going to solve a quadratic equation, we're talking about finding its zeros, its solutions. Sometimes we call them roots. And really what we're getting down to, what all these words really mean is the x-intercept. That's what they all really mean. So if we're looking at this graph here, we can just do some simple calculations to figure out what this equation for the quadratic is. So we know the standard form is, again, y equals ax squared plus bx plus c. If you look at this graph, you'll see that it crosses the x-axis at 2 points, which we can clearly mark, right? This is x is crossing, or the parabola is crossing the x-axis at 3 and -1. Well, it turns out that if the solution to the equation is 3, positive 3, then x minus 3 times x plus 1 will get us the standard form for the equation. So if we expand this, if you remember, we used a double distribution method. We said x times x, that's x squared. X times minus 3, that's minus 3x. And then we did the same thing with this term. We said 1 times x, that's positive 1x. And 1 times -3, that's -3. And then we always had to group together these middle terms. And so the final standard form would be x squared minus 2x minus 3. That's your equation for this graph. And the zeros are -1 and positive 3. Those are the zeros for the expression. So how do we come up, if we don't have a graph, how do we come up with those zeros? Well, if you have this equation right here, if you have the standard form, you can factor it. When you factor it and you get x plus 1, right, and x minus 3, then you can simply say, well, that's where y, remember we said this is equal to y? Let me try again. Let me start from scratch here and explain myself more fully. Here. Let's say the standard form, we figured that out. We're actually given that. X squared minus 2x minus 3, okay? Let's factor this. When we factor it, we're going to find that y is actually equal to, let's use our x method. Let's do it like this. Let's make an x and we'll say, okay, on top goes the product right here of a and c. So a is 1, right? There's an implied 1 here, and c is -3. So -3 goes on top, and the b term goes on the bottom. Okay, so b term goes on the bottom. Now I'm thinking, what factors of -3, what factors of 3 could make it so that I could end up at -2 when I add them together? And so I'm going to use 3 and 1. If I use 3 and 1, if I were to make this negative, then I would get -2 when I add them together. So to say that in another way, y equals x minus 3 and x plus 1, like we discovered from the graph earlier, right? So here's my factored expression right here. Here's the factored form, okay? And from here, what I'm telling you is at the intercept right here, at the intercept where the graph crosses the x-axis, well, what's the value of y right here? Y is 0 right there. So I'm going to put 0 in for y. And I'm going to find the values where y is 0. There's actually 2 of them. So right here, what we're encountering at this stage is the zero product property. If I say a times b, I'll try that again, that didn't look like an a at all. If I say a times b equals 0, then it turns out that actually a is equal to 0 and b is equal to 0.
NHS, please report to the small gym at this time for pictures. Students that are in SGA and NHS, please report to the small gym at this time for pictures.
Sorry about that. This is called the zero product property. If I say a times b is 0, then a is 0 and b is also equal to 0. And so what I'm saying here is this, that actually x minus 3 is equal to 0 and x plus 1 is also equal to 0. And so x equals 3. I just move this 3 to the other side and I get x equals 3. And then this 1, I'm going to move that to the other side of this expression and I get x equals negative 1. And these two numbers, do they look familiar? They should, because those are the zeros of this equation. So negative 1 and positive 3, those values can be found by factoring the standard form and then setting that standard form equal to 0 and solving for x using the zero product property. So let's get back to what you really need to learn how to do right now, and that is to use the zero product property to solve expressions. So we're going to use the zero product property to solve an equation, okay? And the idea is, again, a times b equals 0. If that's true, then a equals 0, and so does b. So if I have a factored expression right here, a factored quadratic expression, then what I know for certain is that at the x-intercept, okay, where this parabola crosses the x-intercept, or the x-axis, I'm sorry, where this graph crosses the x-axis, that is where y equals 0. So I'm putting 0 in right here, and then I'm going to solve for x using the zero product property. I'm just going to say x minus 2 is equal to 0, and x plus 4 is also equal to 0. And then I'm going to move the 2 in this expression to the other side, so it's x equals 2. And I'm going to move the 4 to the other side in this expression so that it's x equals negative 4. So if you're looking for, if I say, what are the solutions to this expression right here, what you're going to say is use a brace, and then you can put a set in the brace. This is not x and y. This is two x values that solve this equation. So it's 2 and negative 4, and then you can close it with another brace. All right, let's try again. So here, in this expression, x is equal to 0, and x plus 4 is also equal to 0. So I'm just going to move the 4 to the other side so that x is negative 4. And now I've got my two solutions. Here's my brace for my set. I'm going to do 0 and negative 4, and then close with another brace. All right, one more time. So for C, what I'm saying is that x plus 3 and x plus 3 multiplied together is equal to 0, right? And then I'm saying x plus 3 is equal to 0, and so is x plus 3. And you can see that I'm going to get the same solution. I'm going to get x equals negative 3 in both cases. So there's only one solution to this equation, And so we'll just put that in our brace like this, -3, and close it. And so there you have it. That's how you solve an equation using zero product property. And remember to put your two values, if you have two values, in braces and not parentheses, because this is not saying x and y. That's what we do when we use parentheses. We're saying this is two values of x that solve the expression.